all should have your notes in front of you. 5.2, right? Guys, 5.2, we're gonna kind of look at the same thing that we did. Now, the one thing that I'm gonna maybe encourage you guys today to do is, remember we used decimals for checking solutions graphically yesterday, and I would encourage you maybe to use that to confirm the stuff that you're doing today. But we're gonna kind of be doing the same thing today, looking for systems of equations and solutions that exist for those. But instead of looking at things graphically today, we're gonna start looking at things algebraically. Right? And we're going to talk about one method today that's called solving systems of equations by, here's the key idea today. You might want to underline this. But the key idea or the key concept today is to solve systems of equations with substitution or by substitution. All right? Remind me again, how many equations are we looking at when we're dealing with systems? Two. And in each equation, how many unknowns are there?
4. 2.
It is, well, there's 4 total variables, but in each one there's an x and a y. Okay, so each equation really has how many unknown variables? 2 of them. Okay, good. All right. So the question we're trying to ask today is, how do we use this substitution method that we're about to look at to solve systems of equations? And in order to maybe answer that question, we've got to be able to solve systems of linear equations by substitution. And then we're going to look at some real life situations that present themselves in this. Guys, the vocabulary is very similar. In fact, I think it's exactly the same as what we talked about in 5.1. So let's take a second and fill this out here quickly again. Remind me what a system of equations is again. How many equations?
2.
With how many unknowns? Okay, so I'm going to say it's 2 equations. With 2 unknowns. And an example that I'll use right here. Maybe an example again that I'll use. Maybe we'll have something like 3x plus 4y equals 48. And then maybe we have y equals 12x minus 16. Okay? So in the example I've got up there that you're getting down, how many equations again? 2. And in each equation there's an x and a y, so 2 unknown variables. All right? Yesterday when we were looking at solving systems of equations graphically, we were looking for the one point where the lines did what? Cross. And I talked about this idea. I said that, you know what, systems of equations is like a situation where you're killing 2 birds with 1 stone. It's the one point that's on both lines, okay? So you just want to write down that the solution for any system is going to be an x comma y ordered pair that makes both equations true. Okay? It's going to be the x comma y coordinate that makes both equations true. All right? So if you think back to 5.1 when we're solving stuff graphically, these definitions look familiar. They're exactly the same, aren't they? Aren't they exactly the same? Would you agree with that? Okay. So let me minimize this a little bit. Let's talk about this idea of substitution and what's really going on here. All right? Now, do you guys agree that you could take and punch this into decimals right here, find your graphs, look at your graphs and find the point of intersection and get a solution? You could. The thing that we're going to be looking at as we move forward in here, when we get ready for a quiz and get ready for a test, things that I'm going to be looking for is, can we do this now using this method called substitution? All right? I'm probably going to need a little resistance on that, and that's okay. But what this really means is you're going to have to do this now. Show us some what? Going to have to show some work here for this, all right? And this really isn't that bad, okay? And I'm going to show you how to do this. Let me ask this question, guys. If I had a $5 bill, and I walked down to the office and they said I need change, what are some possibilities they might give me for a $5 bill? Say again? For a $5 bill.
Oh, $5.
$5 bill, Keegan. So how many quarters could they give me? Well, let's just say this. If they gave me 4 quarters, that'd be $1 back, right? What else could they give me besides 4 quarters to get back to my $5 total? They could give me 20 quarters, couldn't they? Okay. They could give me 20 quarters. It's a lot of jingle in the pockets. They could give me 20 quarters for that. So I could say for that one $5 bill, we can substitute in 20 quarters. Is there another way I could substitute in for $5? Maybe 5 $1 bills. I could substitute for that. So this is kind of the same concept today, guys, where you see a $5 bill, maybe you pull a $5 bill out and you insert 5 $1 bills. Or maybe you're Keegan and you like silver a lot and you put in 20 quarters. That might be the thing that you want to do. Okay? Key concept today. Solving systems of equations by substitution. I'm going to kind of divide this up a bit. Okay? We're going to put down our concept over here on the left as to how I think you should solve this. And then we're going to go ahead and work this out. Okay? I'm going to put some rules down here in terms of how do you solve a system of equations by substituting. Rule number 1 is this. The first thing you always want to do is to look for or try to find or try to look for or try to find isolated variables. And maybe I should write it as look for or try to, I'm going to put another word in here. I'm going to say look for or try to get an isolated variable. Okay? When I say an isolated variable, I'm talking like a letter, y. It's all by itself on one side of the equation. Now that might happen in the first equation, or that might happen in the second equation. I just don't know where that's going to be. Guys, in this first example, is there any one variable in the first or second equation here that's all by itself on one side of the equal sign? Is there any one variable that's all by itself on one side of the equal sign? Okay, so in the first or second equation, Parker? First equation. Take a look at the first equation, kids. Isn't y all alone right here? Isn't y all alone right here? It is, isn't it? This is like my $5 bill. What's y equivalent to over here? What's it say y equals? Negative 2x minus 9. You bet. This y is equal to this mess right here of negative 2x minus 9. Okay? This is kind of like saying, hey, I have a $5 bill equal to 5 ones. Or I have a $5 bill equal to 4 quarters. Okay? Can I replace a $5 bill with 20 quarters? What did I say? 4 quarters last time? Can I replace a $5 bill with 20 quarters? I could, couldn't I? Could I replace a $5 bill with 5 ones? I could, couldn't I? So what this is really saying is this. If y is equal to what I put in parentheses up here, go down to your second equation, guys. There's that y right there. If y is equal to this mess I put in parentheses, what can I replace this y with that I just highlighted in the second equation in? Couldn't I put in negative 2x minus 9 right here? I could, couldn't I? So let's just check this out. Let's see how this works. I'm going to look for or try to get an isolated variable. That's my first goal. Okay? We found y to be alone. So the second rule would be then this. Substitute the isolated variables into the other equation. Now this is a lot of wordiness. There's a lot of wordiness right there. Substitute the isolated variable's equivalent into the other equation. I'll wait a second until you have that down and we'll talk about what that means. Okay, how many more time getting that sentence down? Any more time? I'll let you get that down here. Let's get started right here, kids. Here's how this is going to work. Guys, if y is equal to what I put in parentheses right up here, I'm basically replacing this y with what's in parentheses, because that's what y is equal to, isn't it? Here's how this works. In that second equation right here, we're going to write this second equation as 6 minus the 5, and here's where things get really interesting. Instead of putting y right here, what am I going to replace y with now, guys, from the other equation? So hear me out on this. Anytime you substitute, we're taking y's equivalent and substituting it in for the y value in the second equation. Anytime you substitute stuff, I want you to start to put parentheses around any substitution. So instead of putting y in the second equation, what am I going to replace that y with now again, Parker? Negative 2x minus 9. That's what y was equal to. That's what y was equal to. We found that variable, it's all alone. That's what it's equal to. So in the second equation, we put it in down here. Now guys, here's why we do this. And I need to still say that this is equal to negative 19. In the original equation right up here, how many variables are in here? How many different variables, I guess I should say. There's an x and a y. Now by substituting, instead of having x and y down here, we just have the variable x in here. Those are like terms. We're going to be able to combine stuff and solve for one variable. Once you're able to solve for one variable, you can use that value to solve for the second one. So here's how this works. Once you've got this written all in one variable form now, it just becomes a simple equation to solve. So help me do this. This is going to be 6x. Let's say we need to distribute with negative 5, don't we? So how about negative 5 times negative 2x? What would that be? Wouldn't that be plus 10x right here? And then your negative 5 times negative 9 when you distribute there. What are you going to have, kiddos? 45, so plus 45. And this is going to equal negative 19. Okay? So we've done the distribution. Once we've gotten through the distribution, kids, are there any terms we can combine now? Yeah. Okay, so Parker, you're telling me this is 16x plus 45 now, is that correct? Equals negative 19. Whew. What do you want to subtract from both sides, kiddos? How much, Carlos? Subtract 45 now, great. Okay, so this becomes 16x equals, oh, I think this is negative 64 on the right. What's the last step in solving for x? The last step to solve for x. Divide by 16. You know what, Grace? Negative 4. Good, good, good. So my x value is negative 4. Okay, so we've solved for x. X is negative 4. And I'm going to make a little room up here. So we've got x equals negative 4, okay? So once you know that x is equal to negative 4, rule 3 becomes this. Plug in your solution, or I should say substitute your solution into one original equation. Okay, we want to plug our solution into an original equation. So what that means is this. You have an x value negative 4 right here, right? Guys, if I clean this mess up right here, get rid of all the stuff that's with this up here. Here's your two original equations right up here. Okay, your two original equations are right up here. Okay, I highlight that first equation because that looks like the easier equation to work with. It's shorter. It doesn't have as many coefficients in it. This here says y is equal to negative 2 times x minus 9. Well, what's your x value now, kids? Negative 4. What can I plug in for x right up here now?
Negative 4.
If I plug in negative 4 for x, that's going to allow you to solve for which variable? Y. So let's do that quickly. My y value is going to become the following. It's going to equal, I'm using the first equation, and the beauty about this is the following. It doesn't matter which equation I use. I could have used the second one down here if I wanted to, plugged in for x and solved for y. But you would have y equals negative 2 times, what am I substituting for x in this first equation now, since we know it?
Negative
4.
4.
Negative 4. So 2 times negative 4, I'm sorry, negative 2 times negative 4 minus a 9. Hey, what's negative 2 times negative 4? 8. 8 minus 9 is? Negative 1. So the y value in this case is going to be negative 1. Okay? So in ordered pair form, that would be the point, what comma what? What's the x value for my ordered pair? Negative 4, and the y value is negative 1. Now again, I know that decimals make stuff very easy, and you can get answers that way, but come test time, quiz time, I want to make sure you understand this method substitution, so we're going to have to be required to show a little bit of work. Okay? Right up here are your rules. Look for an isolated variable or get an isolated variable. Then, substitute that equivalency into the other equation. It just becomes a matter of solving some simple equations that we've done so much of this year. Okay, so I'll leave that up there till I know everybody has that down, and we'll take a look at the second example. Questions about anything we just did there? Let me ask this question. Give me a show of hands. Some of you are like, yeah, I think I'm okay with that. Okay, let's look at some more here. Let's look at some more. Anybody need more time this side of the room? Let me know when you got it, okay, kiddos? All good? All right, let's run to page 2. Let's try another example. Okay. Solving systems of equations by substitution. Okay. First equation right up here. Is there one variable all by itself, all alone? No. Is there one all by itself, all alone here? No. So what ends up happening, guys, is this. We need to be able to rewrite. We have to rewrite the system in example 2. So I'm going to just put this down. We need to rewrite the system to isolate a variable. We need to isolate the variable so we can substitute. Okay? Guys, in each equation, is there like a positive 1x or a positive 1y anywhere? Positive y or a positive x anywhere in any part of those equations? First equation, there's a plus y up there, isn't there? Plus 1y. So let me ask this question. You guys know how to get y alone there in that first equation, don't you? What would you have to do to both sides of that equation to get y all alone? Add x. Okay, so we're going to rewrite the system. All I'm going to tell you is you just have to rewrite one equation. So we're going to change this first equation to be y equals what, kiddos?
X plus 3.
Very good. And once you've rewritten one of those, you can keep the other one exactly as it is. So the next one stays the same. 3x plus y is going to equal -1. Okay? So which variable is all alone now after I've rewritten the system? I rewrote this top equation to get y all alone. That's the y equals x plus 3. And then we said, well, once you've rewritten one of them, the other one stays exactly the same. So 3x plus y is equal to -1. Which variable is all alone now after you've rewritten it? What is it? Y is all alone. What's y equal to right here, kids? What's y equal to? It's like your $5 bill is equal to 5 ones. What's y equal to?
X plus 3.
So what are you going to put in for y right down here? What are you going to replace y with in the second equation?
X plus 3.
So let's do that. Here comes the work. Second equation is going to become the following. It's going to be 3x plus, not y anymore, but what? Plus, and making sure I put what around the x plus 3? Because we're substituting, right? So I have to put parentheses. So x plus 3 replaces the y. And then this is still going to equal, what value? -1. Okay? So I had an equation with an x and a y in it. I substituted by y equivalency, and we now have an equation with just x's in it. That's going to allow us to solve for that value of x. So this is really 3x plus x plus 3. What's the 3x plus the what x going to get you, kiddos? 4x plus what still? Okay. What do you want to do now?
Subtract 3.
So you've got 4x equals -4 now. Enough information to solve for x? There is, isn't there? Okay. What's that x value when you solve? What's the x value, kiddos? X is -1. Okay. Now, come back to one of your original equations. I don't care what you do. I'm going to choose the top one to work with, this one. Okay, what am I going to throw in for x now, guys? -1. Okay. Or if you want, you can come right back and use this one. I'm going to use this one, actually. I think this is a lot easier. The one where y is all alone. I would use the one where y is all alone, where x is all alone. Just plug in -1 right here. It says y is equal to x plus 3. What are you going to plug in for this x now?
-1.
What is -1 plus 3?
2.
So what's the y value have to be here?
2.
Y has to equal 2, you bet. Okay. So if I graph those, where would those two lines cross?
-1, 2.
-1, 2. And I think that maybe you should get in the habit of writing your solutions in as this. So the solution here then is -1, 2. Okay, -1, 2. What do you guys think? A little bit of work involved? A little bit of work involved? But if you know the process, it's all really stuff you've done before, isn't it? Okay. Hey, let's take a look at this first on your own. I'll get you started here. I want you guys to try these two on your own and see what you come up with. But in this on your own right here, which variable is all alone right up top here, guys? Y is equal to 3x plus 14, right? So what could I put in the y down here for the second equation? 3x plus 14. I'll get you started on this. 3x plus 14 then would take the place of this y in the second equation. And that would equal -4x. Okay. My suggestion would be subtract 3x from both sides to do that. Why don't you guys take a minute or two And go ahead and try those on your own quickly. And once you've got them, check with a neighbor around you, see if you guys agree. Okay?